Hey, welcome back to the Related Rates Network here. This is another YouTube video for another problem dealing with what we've been dealing with related rates, the Pythagorean theorem. So today, or this problem, or whenever you're watching this video, we're going to be talking about a couple ships. And I'm going to read the problem. Read it slowly, and so you can kind of understand what's going on, and you can replay the video as many times as you like in order to either understand it or see how drawing the diagrams and whatnot. I apologize for background noise. I am recording this next to the voice room, and also there's change of classes and all that other fun stuff. But here we go. At noon, Ship A is 100 kilometers west of Ship B. Ship A is sailing south at 35 kilometers per hour, and Ship B is sailing north at 25 kilometers per hour. We need to find out how fast is the distance between ships changing at 4 p.m. So again, at noon, Ship A is 100 kilometers west of Ship B. Ship A is sailing south at 35 kilometers per hour, and Ship B is sailing north at 25 kilometers per hour. How fast is the distance between ships changing at 4 p.m.? So let's start with our dreads. Remember our dreads? D-R-E-D-S. So let's do a diagram. So we have Ship A, and we have Ship B. Okay, this is 100 kilometers west, so we're going to draw a nice little line here, nice little straight line. There you go. And this ship, Ship A, is going south. So it's going to be traveling in this direction, south. And Ship B is going to be going north. So it's going to be going that direction. So we know that this is 100 kilometers away from each other. And we know that this, we'll call this x distance, and we'll call this y distance. So that means our rate then is dx dt. So our dx dt here traveling is going to be 35 kilometers per hour. And our dy dt, that's how fast the ship, or the speed that the ship B is going in, is going to be 25 kilometers per hour. Now, how are we going to now find this distance? That's from here, as you'll see, this distance from here to there. How is that distance? We'll call it z. How is it changing? This whole distance, that's z, from the tip of where Ship A is to where Ship B is. Well, I kind of gave it away already. You would be responsible for figuring out this was a Pythagorean theorem problem, but I already told you that it was going to be, so we know that the Pythagorean theorem is involved. But how can we make this diagram, this whole situation, a little better for us and to apply the Pythagorean theorem? So let's do this. We know that this is what we're trying to find, so I'm going to select it if I can. Yep, I'm going to copy it, and I'm going to paste it down here. Yeah, not both of them. Just one of them. I know you guys are laughing, and girls. So there it is. There's that z that we found. We know that the distance here, this is still 100 kilometers. So we still know that that is 100. Now, how do I get this side of the triangle? What I do to get that side is we know that this distance, whatever it may be, and this distance, whatever it may be, can be translated and moved. So I can move this and move it over here. And what that does is it gives us the third side of our wonderful triangle. So that's this right here. And I should probably make it blue because our other direction were blue. So let me see if I can do that. How cool is that? All right. So we know that this distance, the top we'll say is y. And down here is x. And that the total side of that triangle would be the sum of those two values, x plus y. Purposeful pause here so you can kind of just stare and look at everything that's going on. We just translated this distance x and this distance y. We just kind of brought it over, brought this guy, and if I could select it, let me see if I can do that nicely. Yeah, I just did that. That's all I did. The distance. Don't worry about the 35, but just the distance. So there it is. So now what we're going to do is we're going to go to the next screen. We're going to use this information to now solve it. So I need a formula. We said it was Pythagorean theorem, so we know the Pythagorean theorem. A squared plus B squared equals C squared. Now we know that our one side, our hypotenuse of the triangle, was Z squared. And then we knew our one side was going to be 100 squared because that was our constant. That was that distance between the two ships. And B, if you go back a slide, B is going to be this side of the triangle, which is going to be this quantity x plus y. So this is going to be x plus y squared. So now we did diagram, we have our rates, we have our equation, and now we are going to take our derivative. So we know the derivative here. And actually what I'm going to do is I'm going to pause this video. We're going to call this Related Rates 3. The next one will be 4, because I don't want YouTube kicking me out and saying that the video is too large. So this is a to be continued, and you'll see that in just a moment.